Glad to be here. My talk also connects nicely to Marcel's. What do we do wrong? So I will also talk a bit about that part in my talk. So the topic is how can we connect neuro-symbolic AI like knowledge graphs and large language models. For example, language models are now everywhere. We also heard a lot in the first talk about visual models or language models to some extent, but I think they will not solve all our problems. So if you ask, for example, ChatGPT to write a summary of the developments about the widely publicized scandal involving Professor Auer, this is me, yeah, it will come up with a perfect story, yeah, what plagiarism, data manipulation, misappropriation of research funds, and so on and so forth. Of course, it's all not true. I don't know if it works still. Actually, I had to trick it a bit. I started in the beginning, described the scandal about Sören Auer. And it created a nice description of a scandal, but 2 weeks later, it didn't work anymore. Apparently, the guys at OpenAI, they are constantly looking what people are asking and rating these answers. You can rate it yourself as well. And they, of course, trained the model in order to prevent such things. They try to reduce this confabulation, yeah, or the hallucinations, actually. And then 2 weeks later, I had to already become more creative. And here you see, for example, you are a journalist, so you have to really trick the system a bit so that it continues to hallucinate. So this is one approach, of course, trying to reduce the hallucinations by incorporating this learning, but you will never completely be able to do that. Because these language models, they don't really have an understanding of facts, of factual information. Yeah, it's just statistic correlations. It's maybe very similar how our human brains work. Yeah, we can also only memorize a very limited number of facts, right? So you cannot really memorize all the dates in history, for example, or all the postcodes and so on. And I think the same with the large language models. So they have the same, I think they have the same deficiencies like our human brains. We also confabulate, we sometimes hallucinate, we believe in false information, false facts. Yeah, Marcel had shown nice examples of fake images, which look perfect to me. Yeah, I would have believed they are right. And similarly, I think these neural models also create a lot of course, many things are right. They get a lot of things right. They are very useful. But some things they get also quite wrong and have similar deficiencies. We have actually developed techniques to deal with the deficiencies of our brains. Yeah. So what is that? We write books which are peer-reviewed, articles which are peer-reviewed. We create databases. We do experiments. We simulations. So we test what our brain produces with other brains and also with the reality. Yeah. And that's something which I think we have to train these neural models to do as well. How can they do that? Of course, and I think just feeding them with more text will not suffice. Yeah, so that's why I think we need to connect them with symbolic representations of knowledge, and that's the combination of neuro and symbolic AI. We want to do that by putting a knowledge graph in between, maybe even something a bit more advanced than traditional knowledge graphs. Who of you has heard about knowledge graphs? Oh, quite a few. That's great. Then I don't have to tell you that much about it. So, but here is an illustration of a knowledge graph. So actually, I built one of the first, or maybe that first knowledge graph. It is DBpedia. So 15 years ago, we extracted information from Wikipedia. And in the beginning, I thought we will just get nice tables of people, organizations, places. But it turned out that everything is connected, yeah? Of course, people are born in a city, they died in a city, there is a certain date. They are citizens of a country, yeah? The country has a president. So in the end, what turned out is that we not have just lots of small tables, but we actually have really a connected space of knowledge, and that became the DBpedia knowledge graph, which you can see up here on the right. Some example, yeah, Bob Dylan was born in the United States or lives in the United States, born in Duluth. Steve Jobs is a fan of Bob Dylan. Then you have attributes like birthday, name, and so on and so forth. So that's a knowledge graph, entities, relationships between them, and attributes. And DBpedia became the nucleus of a whole space of these kind of knowledge graphs or linked data sets, which are published on the web. So what you see on the left-hand side on this slide is actually not one knowledge graph, but it's the network of knowledge graphs which are published on the web. And this is already quite outdated. Meanwhile, I think it's even much, much bigger, but already here you can almost not see any of the bubbles. So each bubble is a large data set, knowledge graph with like billions of triples of statements, and they are connected with each other and they can be used for various applications. So what is a knowledge graph? It's like a fabric of concept, class, property, relationship, entity descriptions. It uses some knowledge representation formalism, and that makes it also different from property or graph databases. Graph databases, of course, they also have entities and relationships, but they don't use this formal knowledge representation formalism. They don't use worldwide unique identifiers. But of course, you can use a graph database or property graph as a basis for a knowledge graph, but you have to add something on top. It's also, so typically for this knowledge representation, RDF schema, OWL are used, W3C standards. Also, it's relatively holistic in the sense that it covers multiple domains, multiple sources, different levels of granularity. It can include instance data from open sources like DBpedia, for example. Or meanwhile, there's also Wikidata, which is directly integrated into Wikipedia. Private data, for example, along supply chains. We work with a lot of companies exactly on exchanging information along supply chains, or really close data only inside one company, for example, like product models, product data, and so on. And then it can also include derived aggregated data. Also, the schema information is included in the knowledge graph. So not like in the database where you have the data and the schema. In the knowledge graph, it's all in one representation, metadata as well, taxonomies, links between different also external entities. You can create also mappings to data which are stored in other systems or relational databases, for example. And that's a slide from Frank from Harmelin, from already 5 years old. Yeah, so these are the logos. I think meanwhile it would be a much bigger wall of logos from companies who publicly develop knowledge graphs to organize their enterprise information. So there are a number of opportunities to integrate knowledge graphs with also this Neuro-Symbolic AI. I think we need to extend the concept of knowledge graphs and also include a human in the loop, and that's this human-machine collaboration. And to tell you a bit how, what are the strengths of knowledge graphs compared to these language models? Yeah, so language models are very good at text processing, at extracting information from text, at summarizing, translation, generating new descriptions, synthesizing information from different texts. Yeah. But they have absolutely no concept of facts, still get often and sometimes factual information right, but that's more by chance than really by default. Knowledge graphs, on the other hand, they are good at knowledge representation and integration, and they are also not black boxes, but humans can actually scrutinize the information in the knowledge graph, right? I've shown you the graph, you can look at it, you understand what's going on there. If you look at the neural network, you don't understand anything. It's also nodes and links between the nodes, but there are only numbers and weights there, so you don't really understand what is going on. Similar as in our brain, you can maybe measure what's going on when you are happy or when you sleep, but not for every neuron you could identify what is actually responsible for. And that's why these language models contain hidden biases. So they are also often a bit superficial. They don't have detailed domain-specific information, contextual information. Yeah. Also, they are quite computationally expensive to train, to fine-tune, and also to query. Like querying a language model is like order of magnitude more expensive than running a database query or a query on a knowledge graph. Also in the knowledge graph, you can trace provenance. It scales relatively well, but requires human integration and curation effort. So you see a bit they are quite complementary, yeah? And that's exactly what we are trying to do, combining knowledge graphs with these language models. So the knowledge graph, they can represent a base of validated, trustworthy knowledge, yeah, which can be used by the language model via retrieval augmented generation, for example. They can help organize enterprise knowledge from various sources. They can provide domain-specific information input for domain-specific training and fine-tuning of the LLMs. And the language models, on the other hand, or the neural models, they can help curating the knowledge in the knowledge graph by suggesting and recommending things. They can create mappings, queries for the knowledge graph, which can then be validated by the humans. And they can become a front end for human interaction with the knowledge graph. So how can we, or I want to show you now an example after these ideas, how we build such an integration and how we work on that. And here I would like to also go back to what are we doing wrong, yeah? So here I have some examples of domains which were completely disrupted in the last 20 years, yeah? So the first one is mail order catalogs. Here in Germany, there was Quelle and Otto. I guess in other countries you had different companies. So they were publishing every year a big catalog, 500 pages of paper with all the product descriptions and prices, yeah, and then you could order these products from these catalogs. It was a huge business 20, 30 years ago. You see here actually the last of these catalogs with Claudia Schiffer. So meanwhile, no one would order something from such a catalog, even if you now scan it and send it by email as a PDF. Previously, it was really shipped by post, and you had a kilogram of these catalogs. Was a big logistics effort, but now you could, of course, scan it as a PDF and then send it around by email or download it. I think no one of you would order something there. Or would you use a PDF scan of a street map, yeah, for navigating from A to B? I think no one would do that. You wouldn't use a phone book anymore nowadays. Or an encyclopedia, even if you get it as PDF, yeah, 500 pages as PDF document, you wouldn't use it because there are better means to do that. Yeah, we use Wikipedia, we use Google Maps or OpenStreetMaps. We use e-commerce websites like Amazon, eBay, Idealo. And these are not just pseudo-digitized versions of the analog copies. Yeah, these are not just PDF scans of what was there before, but they are really from the ground developed digital services, yeah, which completely disrupted the business models. So we have much more focus on data, on interlinking of data services. Crowdsourcing plays a big role, curation, yeah. If you use Google Maps, for example, you actually contribute to the data there, yeah. How frequently you visit the Novotel here, for example, there will be a spike now because so many people are attending the conference, yeah. There is a higher a number of visitors. Here, sometimes they ask you questions, are the opening hours still correct, and so on. And when you click yes or no, you actually help Google to improve his knowledge graph. Yeah, so Google has a knowledge graph in the back to fuel these different services. So what about we in science? How are we working on? And we actually spend worldwide 1.7 trillion, so it's not million, it's not billion, but trillion on research and science. It's a huge amount of money. Do we spend this money right? And my impression is we don't. We actually work a bit like 400 years ago. Yeah, we still publish the same papers, and we are drowning in a flood of publications, and no one can really make sense of this. And if you compare it to these other domains, yeah, it would be like ordering something from a PDF scan of a mail order catalog or using a PDF scan of a street map for navigation. No one of you would do that, but in the research, we do it. Yeah, we use PDF scans of the papers, and we produce so many papers that almost no one has an overview anymore. That creates a huge number of problems. Yeah, digitization of science is not really working. We have a reproducibility crisis because the information which is required to reproduce the stuff is not contained in the papers. Of course, we try to publish now source code and data, and sometimes it works a bit, but it's also not linked. The data is here, the source code there, the paper somewhere else. Yeah, to figure out how to put this together, and that makes it so difficult for industry also to use the stuff. Is extremely cumbersome. We have this flood of publications. Actually, the publication output doubled in the last year. And we have a deficiency of peer review. The more publications, the more peer reviews you need. Everybody has less time, has less overview, and that makes it extremely difficult. Yeah, so transparency, a lot of information is hidden in the text. We cannot really fit different research results together. There is a lack of machine assistance. These language models, they produce a lot of garbage when you ask them about research questions. There was actually a language model developed by Facebook exactly for research, but it produced so many hallucinations that they had to shut it down. Yeah. So for research, I'm skeptic the language models will help us a lot. So the publication flood here is also a screenshot, which is already 5 years old. When you search for CRISPR, you get 250,000 results. Meanwhile, I did it a few days ago, you get more than 1 million results. And if you're then interested, it's a genome editing method. How good is it? What specifics has it when you use it with insects? Who has applied it to butterflies? You're completely lost in the space of publications. So that's a bit depressing, but how can we fix it? And we actually work on this knowledge graph to represent information, scientific information, like research problems, definitions, research approaches, different types of artifacts, publications, data, software, images, audio, and then these domain-specific concepts in such a knowledge graph where we have to clarified what are the entities. Yeah, in mathematics, you have definitions, theorems, proofs, methods. In physics, experiments, data models. In computer science, concepts, implementations, evaluations, for example. And then you can really represent it in this kind of more semantic, universal knowledge graph or knowledge base. And we hope that this will become a bit a lighthouse in the flood of publications. And now let me show you how it works in practice. So I'm opening here my browser. This is the Open Research Knowledge Graph, and that's exactly where we also integrate this kind of neuro-symbolic approach in there. So it's meanwhile not only a knowledge graph, but we integrate it also with the language model. You can go here into different fields of science. For example, you can go to engineering subfields, and then below you have overviews of research questions here, and we call this comparisons. Not papers, but summaries, basically, of a research question. So let's, for example, check out this here, comparison of studies on Germany's energy supply. Yeah, it's a big topic. How can we become carbon neutral till 2050? So there are a lot of studies which analyze, calculate simulations, how we can do that. So there are actually 25 of these studies. Each of these studies is like 20 pages long. So if you download all the PDFs and want to read them, you have a pile of 500 pages of paper to read through. And if you want to know how many, for example, gigawatt renewable energy do I have installed, you have to read all this, compare it, make sense of it, yeah, and then maybe you can answer this question. So what we did here, we actually entered the gist of this information into this knowledge graph, and what you see here is a view of this knowledge graph, which is a tabular view. So for each of the publications, we have a column here in this comparison, and in the rows, we basically have a description of the gist of the information from this publication. So for example, what energy sources does the study consider here? The first one considers bioenergy, geothermics, hydropower, and so on. Then what kind of scenarios do they calculate? For example, the first one, 100% CO2 reduction till 2050. The second one, only 95. Yeah, and so on and so forth. And you have basically a table with 25 columns here, and then also a lot of rows. Yeah, it's, I would say, already a bit easier to digest than 500 pages of paper, but still not so, maybe not so intuitive, especially when you give it to a politician. He could hardly make sense of this table. For researchers, already better. But the advantage is that this is actually in the knowledge graph, so it's also machine readable. Yeah, it's not only textual information somewhere in a PDF, which is hard to make sense of, but it's already well organized in a semantic database. And that's why we can actually use it for creating visualizations, dashboards, all kinds of summaries here. And what you see here, for example, is now the reported installed capacity required compared with the different studies. So some studies think we only need 150 gigawatt capacity. Others think we need more than 800, but the majority probably thinks 400 should be sufficient. Yeah? And that would, for example, politician help to make a more informed decision, because he can see, oh, looks like the majority of the researchers think we need around 400, 500 gigawatts, so then we should be on the safe side. And then the politician could make a plan how to get there by changing the legal framework, for example, in such a way that it is facilitated to build this capacity. So this is just one example. So there are many more examples in many different domains here in the Open Research Knowledge Graph. Maybe I show you actually, you can also look at the graph. So if you go here on the right-hand side, you can export it as LaTeX. If you write your paper in LaTeX, you can directly integrate it into your paper. And different other formats. You can launch a Jupyter notebook, so right from there, and you have all the data, and then you can run some additional analysis. And you can, of course, also view the graph. So if you click here on View the Graph, it shows you the graph. But maybe figured out that this graph view, you see here, it's a lot of nodes and edges. It's not so intuitive, so this tabular view is actually more easier to consume for people. And there are many other ways how to present information there as well. Question is, of course, how do we get in there, get the data in there? And let me quickly sign in. So once I'm logged in here, I can actually click on the edit button. So we, of course, research on how to create this automatically. The bad news is, unfortunately, creating this knowledge graph fully automatically doesn't work very well. We get maybe 50, 60% precision recall, which is not bad. But it basically means 1/3 of the information is either missing or wrong, yeah, and that would not be so usable. That's why we really need the users in the loop. And that's what you can do here. You can add, for example, another property, but I can also show you here these light bulbs. So that's where the language models, the neural models come into play. So when you click on the light bulb, it basically submits the information about the paper, like the title, abstract, sometimes parts of the full text, to the language model and asks for suggestions what could be added to the knowledge graph. Yeah, and then you can basically select here a property, for example, has location, yeah, and this is added, and then you can add a value. You could again launch the light bulb, but I can also start typing something, for example, Berlin. And while I'm typing, it searches in the knowledge graph for existing entities and relationship entities in that case, and not only in our knowledge graph, which is the ORKG, but also in other knowledge graphs. So you see here geonames, for example, Wikidata. So this space of linked data graphs, which I've shown, is actually searched, and you can connect and create links also to other knowledge graphs. So I would maybe link here to Wikidata, to this one. And the advantage is, once I have done this, I can just click on it, on the resource, and it loads me all the data from Wikidata. Yeah? You see it here, Wikidata, and I have all the structured data from Wikidata, like the geo-coordinates, the mayor, and so on and so forth. So I don't have to add everything myself, but I benefit from all this data which is out there on this web of data, basically. Yeah, so this is maybe a short demo in the interest of time. So I can skip the slides here, which I had prepared. And a last topic maybe is that we want to integrate this this neural network with the humans, because NLP techniques or even the language models, they create errors and hallucinations, and it propagates. So in order to have a good quality, we try to have machine in the loop or human in the loop approaches. Yeah, so this in the middle, where the human validates information which is added, or the machine suggests things while the human is working, as I just have shown you. And there are various techniques. I've shown you just one example, but you can also annotate abstracts. You have these light bulbs. Here's the abstract annotation, for example. You get suggestions about the materials, about the data, the methods, which could be added to the knowledge graph there. Yeah, and the Open Research Knowledge Graph is, of course, a big effort. So there are a lot of people involved here. We do this at TIB, Leibniz Information Center for Science and Technology. We are also involved in many of the national German research data infrastructure initiatives, NFDI, where this is part of. So the example I've shown you, for example, is part of NFDI for engineering and NFDI for energy. And there are many more things I could talk about, but I think we are running out of time, and I would like to give you also the opportunity to ask me some questions. So thank you very much for your attention.